And you see one disposal pile. This is underwater disposal system is fine discharge point for pre-treated produced water and is designed to contain any upstream offsets preventing unnecessary discharge violation. So, this is the last stage of water disposal for offshore application. Okay. So, disposal pile will be like 24 to 48 inches diameter, this one. Okay. An open ended pipe. So, this side open, this side upper side also open actually. Attached to the platform extends below the water surface, concentrate platform discharge into one location. So, all the discharge will be going to this pipe actually. Okay, there will be different separate mechanism, I will discuss later further. It will be discharged deeper, not on the nearby surface, water surface. Okay. Useful for deck drain disposal. So, deck will be some draining mechanism. So, the water or no, or whatever produced water or unused water is there. So, it will go through this piping system. A small amount of separation occurs in disposal pile. No significant treating process happens. So, treating process happened already. So, this is a disposal system. So, you are not actually basically you are not purpose is not to separate here anything. Okay. You are this purpose of disposing, but small amount things are there, how to dispose separate I will explain later. Large diameter open ended pile, these are. Okay. So, and this design you see, this one is a long pipe actually. Okay. So, I have taken one company website and this is clean water out, clean water out. Okay. And here produced water coming in, produced water. Okay. And this is vent and oil outlet. Okay, if there is any small amount of oil, so some separation will be going on and that will be going out. Okay. So, major separation will not occur here. So, this is disposal water. Okay. So, produced water, disposal water, anything is there, they will be putting in single pile. Okay. This is your, you see wave action here, water level. Okay. So, one of the disposal pile is called skim pile. Okay, skim pile, there some separation will be going on. So, a type of disposal pipe is called skim pile. Multiple series of baffle plates will be there, like these are baffle plates. Okay. These are baffle plates, you can see. Left one is open caisson, there is no baffle plate. Second one skim pile they are saying, third one is saying petro pile. So, there is some other mechanism also available there. So, sand must be disposed of without free oil. So, oil is not allowed. So, sand is having some oil content, that also you have to separate. So, they will be putting sand also there. So, everything will go down to the seabed. So, if you see here, oil and let us say oil water entering, okay, it will go like this, it will go like this, it will go like this, it will go like this. Okay. So, water coming out. Now, what is happening when it is going through this? So, there will be one quiet zone. Okay. There will be one quiet zone. So, quiet zone what will happen? So, oil particle will be collected here. Okay. So, it will be like this. I will draw again. No, like this. It will be vertical like this. Then oil water coming like this. Then another will be coming like this. Okay. So, oil water mixture coming here. Okay. And when it is crossing this one, this area you see quiet zone, no disturbance almost. Okay. Almost no disturbance. So, this is quiet zone. So, what will happen? You collect oil here. Okay. Oil will be going through this one up. Okay. And water, it will go down, it will go out. So, wherever quiet zone is there, multiple baffles will be there. So, you are creating several quiet zone. So, that quiet zone will allow, if any remaining oil is there, so it will be settling and it will move up. Okay. So, small amount of oil also you can separate here. And if you have sand, so sand because of heavier, sand will go down with water. Okay. Sand also will get enough space and time there inside baffle, quiet zone they will get, you will get separated, then you dispose it. Okay. This is offshore system. So, disposal pile, a large diameter pipe, open ended pipe concentrate all platform discharge into one location. So, disposal pipe, all platform water will be collected into one location. Okay. Then provide conduit protect from wave action, so that discharge can be placed deep enough to prevent sheens from the occurring during upset condition. Provide an alarm or shutdown point at the event of failure also. Okay. Drains. So, drain, it will be connected to pressure vessel. Let us say if you have closed drain, so it will be connected to pressure vessel. If you have open drain, then it may not be connected to pressure vessel. It will be like atmospheric or gravity or open drain. Okay. So, collects liquid, spill over on the ground. So, all the liquid will be collected and it will be going through this open drain, then pile. Okay. Liquid collected in open drain, rainwater, washed down water or contaminated water, these water will be collected in the drain. Okay. In the offshore application. Now, I got this summary actually from Water Environment Foundation. They have done good summary like gravitational separators, CPI, hydrocyclone, where it is used and what are the different comments they have made table. For example, dissolved gas flotation, no use for offshore application because it will take lots of space. Okay. Chemical, sometimes they are using for destabilizing colloids or emulsions, so that separation will be quicker. So, in that case applicable in all cases, offshore, onshore. Okay. Most oil and oily solids are stable in the produced water. So, destabilization is necessary. So, in that case some cases you can add chemical also. Okay. Otherwise you can read through this all the points. So, now we will go to one problem. This is the last section of this oil water handling system or water disposal system. Let us say one field separator system, separation treatment plant, it is having separator like horizontal, vertical, horizontal, square, rectangular cross section. So, what will be the sizing calculation? Okay. So, assume water flow rate Q water 8000, maximum oil droplet size 500 micrometer for this condition. Okay, 500 micrometer. dm, maybe I can write initial I. Water viscosity mu water 1.1 Cp, water specific gravity 1.07. So, rho water 1.07, rho oil 0.87, and it reduces oil content 800. Initially it was 2000, reduced to 800. So, oil content, we have to put some name. Okay, I am not giving any name now. Water retention time T water 10 minutes is given. Okay. Find dimension for the required treatment, horizontal cylindrical schema if I am using. If I am using horizontal rectangular cross section, if I am using vertical. So, what will be the calculation for that? Okay. So, we have gone through all the formula actually. So, we will start one by one. So, here actually they are using one formula for droplet sizing, they are not using 500, rather they are using one formula for this droplet calculation, but in exam I am thinking to give one fixed droplet size. Okay. So, droplet for calculation they are using droplet size, this 800 water 800 divided by 2000 initial droplet size, in linear relationship they are assuming. Okay. This is 500. So, they are using 200 micrometer. So, I am planning to give in final exam or in the assignment a fixed diameter, so that you do not have to guess or you do not have to remember this formula. Okay. And for settling, now we have two equations, settling calculation based, particle settling calculation based formula. So, for horizontal cylinder. Okay. So, for that DLEFF you can go through previous lecture. So, formula is like 1000 QW mu W divided by del SG dm square. Okay. Now, if we put directly the data, 1000 is constant, QW is given 8000, mu W is given 1.1, del SG 1.07 minus 0.87 into dm 200 we calculated. Okay. So, this would be giving 1100. Okay. So, what will be the unit? D inch and LEFF feet, actually inch into feet you can write. Okay. Now retention time based calculation. Okay, retention time based calculation formula is that d square equals d square into LEFF. Effective length, d diameter of the separator. Okay, I should draw actually separator. This is d, this is effective length. It is not seam to seam length, rather it is effective length. So 1.42 TR water into QW. So from this formula 1.42 into 8000 into 10 TRW. So it is coming 113600. Again the unit will be like inch square into feet. Okay. I will go to next slide because this. Okay. So now they have assumed many values actually 60, 74, 84, 72, 84, 96 for D. Okay. And for settling calculation and for retention time, settling effective length and LSS, this also feet, this also feet, this is inch, this is L effective feet, LSS feet. Okay. Retention time based and settling calculation based. So you are calculating effective length and seam to seam length. LSS means seam to seam length. Okay. So you can get all the calculation, just I am showing only one calculation for 84, let us say D assume 84. Okay. So for that LEFF, what will be the LEFF for settling calculation? So for settling calculation formula, if you see DLEFF equals 1000, you got 1100 value. You got 1100 already, right? So LEFF equals 1100 divided by D. It is not equal. Okay, so this value will be coming as 13.1. So LSS, how to calculate? So LSS formula actually I have not given previously. So LSS is equal to 1.33. They have this standard formula, empirical formula, L effective. Okay. So then what is LSS? 1.33 into effective length 13.1. 13.1. So it is coming 17.4. Okay, 17.4. Now for retention time based calculation will go. So in that case again D84 we know. So and our D square LEFF value we calculated 113600. Okay. Now D value 84, so LEFF equals 113600 D square. D already 84, so 113600 into 84 divided by 84 square. So this value will be coming 16.1. Okay, actually feet 16.1. Now what is LSS? LSS will be 1.33 into 16.1. So it is coming 21.41. Okay. So you can calculate all the data, but in exam purpose I want to simplify. So maybe I will give like take D value something and calculate. Okay. So that way I can simplify, or I can ask, okay, take make this table. Okay. Then you decide which will be the optimal, or you on the basis of your judgment if it is in class exam. But if you are giving for online exam, so in that case I have to ask specific digit. For example, what is the difference between LSS or calculated from settling equation, LSS calculated from retention time. So, in that case you will be forced to calculate everything, then finally LSS difference you have to show. Okay. So, this is for horizontal separator. Okay. Now, if you go to horizontal separator cylindrical, now if I go for rectangular cross section, okay, rectangular cross section for horizontal, okay, horizontal. Same process, we know the formula W L effective equals 70. If you see previous formula derivation, 70 Q W mu divided by del S G into d m square. Okay, so this will give 70 into 8000 into 1.1 divided by del S G, already we have seen 1.07 minus 0.87 into 200 square. Okay, so this will be given 77 and WLFF, so it will be feet square, actually both are in feet. Okay, W is width of the system, width, this will be like height, this will be L effective, fine. So, W square formula, this is settling equation, this is retention time, W square L EFF, retention time based, retention time, okay, this is settling. So, in that case 0.008 TRW into QW, okay. So, it is coming like 0.008 into 10 into 8000, it will give 640 FTQ. So, in that case they ask in the book, they ask like assume like 567 W value, okay. Then you try to calculate HW, if you are assuming HW is half of the width. So, W by 2 equals HW, okay. So, equals W by 2, then 5 half 2.5, so 3.5. So, L effective from settling equation, L effective from retention equation, okay. This is settling, this is retention, okay. So, settling equation L effective, if you calculate, it is coming 15.4, same procedure 12.83, 11.0, 26.6, 17.28, 13.06, 06 actually. So, this way you can calculate. So, they have taken actually 6 as a optimal and they calculate further. So, we will go to vertical cylinder for vertical cylindrical skimmer. Okay. So, that formula also we have known. So, vertical cylindrical skimmer, it will be like this, right. So, L effective and diameter we know. So, D square vertical cylindrical, okay. So, D square formula we know 6691, one F term also will be coming because of your factor, right, Q W mu del S G d m square, okay. So, directly formula you put 6691, F initially we assume 1, okay, initially F assume 1, okay. Then QW 8000, mu value given 1.1, del SG actually 0.2 and dm equals 200 you have taken already, okay. So, it is coming 7360. So, d min or square root is there. So, square of 7360. So, this will be coming 85.79, okay. Now, because it is coming more than 48 inch, in the book it is they have written that if it is more than 48 inch, then you have to add f value more than 1, okay. So, let us say initially assume f equals more than 48 inch, D equals D more than 48 inch. So, F value let us say 1.25, okay, you can take higher value also. So, till you reach certain value more than 48. So, in that using that one they got D mean because factor came up. So, D mean into factor. So, it is coming 1.25 into 85.8 equals coming 111.5. Okay. So, after that they are assuming dia equals 108. Okay. So, after that H they are calculating water height 0.7. This formula is given previously, TRW QW D square. So, it is coming, if you put all the values into 10 into 8000. So, D square 108. So, it is going 4.8 feet, okay. And height of the skimmer LSS, okay, same to same length of skimmer height. So, they are adding like H plus 3. So, H means 4.8 plus 3. So, 7.8. So, approximately 8 feet. Okay. So, this is approximate value for height and this is the dia. Sorry, this is the dia. Okay. Lots of assumptions are there. If I am giving class exam, in class handwritten face to face exam. So, in that case actually I will keep this example similar sort of, but if I am giving for online exam. So, in that case assumption part I will write what assumption you have to take in which step, okay. Otherwise everyone will be getting different answer, that will be very difficult to put in computer, fine. So, okay, thank you very much for today's lecture. Next day we will start new topic. Thank you.